Hello, in this demo video we're going to be turning an unsimplified boolean equation into a NAND only logic circuit. And in order to do that we need to first just make a regular circuit out of this equation and then turn it into a NAND only version. So the first thing I want you to notice is that double prime right there. We're just going to ignore that because those two primes will cancel each other out. And we're going to take that x or y prime and make a OR gate with a negated input right there and plug x and y in. I'm using the strategy of going from the inside of the parentheses and go outwards. So if we look at the other side of parentheses, we got z prime or y. So we're just going to move y in there and z to be negated for the input on that OR gate. And we're going to negate the output of that OR gate because there is a prime on the outside of that parentheses. I don't know why that red line is there. Every time I draw, I can't fix it, so you're just going to have to deal with it. Okay, and as you can see next to the z prime or y parentheses, that's with that prime on the outside, that's going to be ANDed with x prime, so we're just going to put in an AND gate with a negated input for x, and then that output being normal. And then we're going to take those two sides and AND those together with no negations either, and that will be S. And it's pretty simple. And now we're going to make the AND gate only version, or sorry, NAND gate only version. I have a reference photo in the corner there, so you can see both versions of the circuit. We're going to start off with the OR gate between x and y, so we need to turn that OR gate into its NAND gate equivalent, which is a NAND gate with each input being negated, and we do that with NAND gates. And because of that, y being already negated, we can just put two negators there and that will cancel them out. So we're going to have y not have a negation, and then x will have a negation, and then those get NANDed together for the OR gate. Next we have the NOR gate at the bottom with also one negation, and that NOR gate is just going to be the same as an OR gate, but with a negator at the end. It's the same story up top, but at the end we're just going to negate that output. So yeah, z with no negation and y with a negation fed into the NAND gate. Now we just make a regular AND gate with one side negated, so that's pretty simple. We're just going to do a NAND gate with another NAND gate after it to negate it at the end, and that will just turn into a regular AND gate. And you'll notice the input's negated for x, and we already have that up there, so we just drag that down. And now both of these two lines we got are also going to be ANDed together, which is just two NAND gates in front of each other once again. And that will get us the output of S. It looks like I forgot to put an AND gate down here. One moment, let me fix that real quick. Okay, that should be it. Thank you so much for watching.